Okay, hello everyone. We are on to lesson 6.5, operations with radical expressions. So radical expression is going to be something with a radical bar in it, be it a square root or a cube root or anything like that. Operations would mean adding, subtracting, multiplying, and dividing. So, and we've already done simplifying. The lesson prior to this was simplifying radical expressions, and that's going to come into play as well. So radical expression can be a simple square root, like square root of 8. You could possibly have a coefficient, so 4 square root of 30. You could have a different index, so various indices. I thought I'd write that down. The plural of index is indices. I think that's a neat word, but whatever. So 2 cube root of 56. So those are examples of radical expressions. Nothing's being done to them. You might be able to simplify them or not, but that's what they are. But let's look at the various things you can do with them, starting with adding and subtracting. When it comes to adding and subtracting radicals, you basically look at the radical as though it's a variable in a sense, because you have to have like terms. So in this example, 5 radical 3 plus 6 radical 3, when you add that, you get 11 radical 3. It's just like adding 5x plus 6x. The 5 and the 6 get added, that's your 11, but the x just stays in x. Here, the 5 and the 6 get added, that's where that 11 comes from, but the radical 3 just remains a radical 3, or you can say square root 3, however you want to say that. So that's the general rule for adding, and the same rule would go for subtracting, very similar to variables. So in this next example right here, 5 square root of 3 plus 6 square root of 2, these are not like terms, so you would just leave it 5 square root of 3 plus 6 square root of 2. There's no way to simplify that. Now the next one is also unlike 5 square root of 3 plus 6 square root of 12. However, unlike variables where you would just stop right there and say that you're done, you can't do anything, radicals are a little different. We can simplify this square root of 12. 12 is 6 times 2, and 6 is 2 times 3. So we do have a pair of 2's there. So we can look at this as 5 square root of 3 plus 6 square root of a pair of 2's becomes 2 squared. That 3 just stays a 3. So you get 5 square root of 3 plus 6 times 2, right? This square root cancels. Square root of 3, and that becomes 5 square root of 3 plus 2 times 6 is 12 square root of 3. And now they are like terms. They're both square root 3. So if I add this, 5 plus 12 is 17 square root of 3. So, kind of like variables, as I explained up here, but sometimes a little different. Sometimes you start off with what are unlike terms and you can't do anything with them. Other times you start off with unlike terms and it turns out you can simplify one of them and sort of force them to become like terms. So that's going to be a bit of the challenge in this particular assignment. Then we get into multiplying. When it comes to multiplying radicals, you do not need like terms. You can multiply anything together. They don't have to be the same type of radical. Now, they do have to have the same index. So you can only multiply square roots with square roots, or in my example here, a cube root with another cube root. But the 5 and the 2, those don't have to be the same. So to multiply radical expressions, you multiply the coefficients by the coefficients and the radicands by the radicands. All right, what the heck is a radicand? Radicand is just the number under the radical bar. So here's how you do this. Multiply the coefficient by the coefficient. That's going to be 6. Bring over the cube root symbol, and then do the radicand 5 times the radicand 2. 5 times 2 is 10. Or instead of, if you don't want to use the big technical terms, coefficients and radicands, I think of it this way in my head. It's the outside numbers times the outside numbers and the inside numbers times the inside numbers. I'll just use out and in because I'm too lazy to write outside and inside. Outside number times outside number times inside number. And then that's your answer. Unless you're able to break this down and simplify it, but 10 really doesn't do anything. You won't gain much ground there. So we'll just call this 6 cube root of 10. Also with multiplying though, you can expect to see the distributive property and the FOIL method. That's going to come up. When it comes to dividing, the final operation, First, simplify roots if you can. If you simplify them first, that ends up taking away a lot of the work. If you can't simplify them, the roots, or for that fact, the fractions, right? You know how to simplify a fraction. If you got, you know, 6/8, you can simplify that to 3/4. It's called reducing the fraction. If you can reduce the fraction before you start doing all the radical stuff, that can help too. So always look out for that. Simplify it before you do the dividing. But once that's done, if you have a square root in the denominator, you have to do this process called rationalizing it. We have already covered rationalizing denominators when the denominator is a monomial. Now, monomial, mono means one. That's when there's a single term. So if you have something like 5 over the square root of 2, we've already covered how to do this. I'm not going to work it all out, but this should sort of ring a bell to you. What's going to be new, so we're going to do a little of this today for review, but what's new is when there's a binomial in the denominator. So if you have something like 2 over 3 plus radical 5, again, you're not allowed to have a radical in the denominator. There's a way to rationalize it, but it's different than what we've already learned like up here with a monomial. So we're going to get into that. We're going to use conjugates. This is a term that we've used also before in this class. We've used it with imaginary numbers, but it does work with radicals as well. So take this example here, 3 plus square root of 5. The conjugate of this would be 3 minus square root of 5. So it's exactly the same, except one's a plus, one's a minus. So we'll get into that when it's pertinent. I think one of my attendance questions was even about that recently. All right, let's not dance around anymore. Let's get into the examples. As normal, I'm going to do the evens and ask you to do the odds. Some of these are going to go pretty quick and easy. Others are going to take a lot of steps, a lot of work. This is spread out over 4 pages, I believe, so that you have plenty of room to work. 26 problems total. Since you only have to do the odds, that means you're going to have about 13 homework problems. All right, let's go. So the directions are simplify. That's pretty generic. Number 2, as you can see, is an addition problem. And we do have like terms. The 6, the radical 6, is not a like term. So you can only combine like terms. So the radical 6 you can't do anything with. Plus 1 square root of 5 plus 1 square root of 5 would be plus 2 square root of 5. Everything is simplified, so we're done. You don't grab a calculator and type in square root of 6 and get a decimal. That's not a thing you do. Let me check number 2. I can't imagine I'd get it wrong, but yeah, there it is. Number 1 is going to be a lot like number 2. Number 3. Now, if you look at this, you do not see any like terms, 6, 27, and 54. However, as I mentioned earlier, you can sometimes simplify these and make them be like terms. Now, this 6, you're not going to have any luck. 2 times 3, there's no pairs of anything, so breaking that down doesn't get you anywhere. On the other hand, 27. 27, as you may know, is 3 times 9, and that's 3 times 3. So we do have a pair of 3s. So let's see, how am I going to organize this? The first term won't simplify. The second term you can turn into 3 squared times 3. Right? There's that extra 3 there. The next term, let's look at 54. 54 is 2 times, 27. That's 3 times 9, and that's 3 times 3. Again, you've got, is that right? 2 times 27, yes. Okay, so we got 3 squared, and then an extra 2, and an extra 3. So now, again, the first term didn't simplify. There's nothing you can do there. The next term, we've already got a 2 out front. That coefficient, that coefficient right there is what I wrote there. But next, we have 3 squared and a square root. So that cancels that out. You can bring out a 3. But this 3 is going to stay underneath the radical bar. Minus, bring down the next 3. Again, the square root cancels out that square. So you can bring out another 3, and that leaves us with 2 times 3 under the square root bar. So now what? Well, let's look at what we got. We have 2 square root of 6 minus 2 times 3 is 6 square root of 3 minus 3 times 3 is, what am I doing? 9 square root of 2 times 3 is 6. Now, I'm going to use the highlighter again. I'm going to change colors just for variety. This term and this term match each other. So I needed to go through all of this work of simplifying the radicals in order to finally get like terms so that I can combine them. If I take 2 square root of 6 minus 9 square root of 6, that's going to give me negative 7 square root of 6. This other term has no like term, so I just copy that down. And that should be my answer, or the answer could be written like this. That's the same exact answer. Both of those mean the same exact thing. Let me check number 4 and see if it's right. And there we go. Now, looking back at this, you might say, wow, that was a lot of work to do combining like terms. You know what, I'm not going to leave both answers on there. That one answer was good enough. Is there any shortcut, any way to get through this work quicker, more effectively? And, you know, the answer is yes, but shortcuts can be tricky. One person might look at a shortcut and say, wow, that's a lot easier, that's a lot better, and be good with it. Others might say, man, you taught me a completely different way to do something I already knew how to do, and now I'm confused. Shortcuts suck. So pardon my, language. Not suck isn't that bad. But anyway, oh boy, I'm all over the place. What I'm trying to say is, yes, there is a quicker way to do this, possibly. I'm going to go ahead and do it for what it's worth. If it confuses you, then just stick with the method that we did the first time, that we've done on other worksheets. But just so I can say that I've done my best to help students, I'm going to walk through this. This shortcut works best when students kind of know their times table. So if you have a pretty good mental math, I'm not talking about being a human calculator, but you know some basic stuff. So here's the deal. 6 won't break down into any square numbers. It's going to have to stay radical 6. 27, if you know your times tables, is 3 times 9. Now instead of making the whole tree like I did over here, if you just recognize the fact that 9 is a square number and you can square root square numbers, that's going to cut out the whole tree and this whole step right here. Same thing for 54. If you know your times tables, 54 is 9 times 6, right? And again, 9 is a square number. So we have 2 square root of 6 minus, what is the square root of 9? It's 3. So bring that 3 out here with the 2. And then same thing here. What's the square root of 3? I'm sorry, what's the square root of 9? 3. Bring that 3 out here with this 3. So we have 2 square root of 6 minus 6 square root of 3 minus 9 square root of 6. Again, these like terms go together. They're both square root of 6, so you get negative 7 square root of 6 minus 6 square root of 3. If you know your times tables and you are comfortable with what square numbers are, you don't necessarily need to do the whole tree thing. Now, which way am I going to do the rest of the worksheet? I want to do it this way because it's quicker and easier, but this is how we did the work on the previous lesson, so it'd be more consistent to do it the other way. Maybe I'll do it the longer, more consistent way, and every once in a while I'll throw in a problem where I do it the shortcut way. All right, let's look at number 6. Same kind of an idea. Do we have like terms? No. Can we make like terms? Probably. So this, well, let's see, how am I going to do this? We'll make the tree. 54 is, again, 9 times 6, and that's 3 times 3, and that's 3 times 2. We've got a pair of 3's there. So this is 3 squared times 3 times 2. The next term, if we do a factor tree, there are no pairs of numbers, so you really don't need to break that down at all. And the next one, 24, is what? 2 times 12, 2 times 6, 2 times 3. Got a pair of 2's there, 2 squared, another 2, another 3. So what happens? I can simplify that. It gives me 3 times 3 square root of 3 times 2. Bring this down. Minus 3 times, okay, 2 squared. I can bring out a 2. And then that 2 times 3 stays inside. That gives me 9 square root of 6 plus 3 square root of 6 minus 6 square root of 6. All three of these are like terms. So 9 plus 3 is 12 radical 6. And then 12 minus 6 is 6 radical 6. And I'm not going to do this problem a second time. You probably don't want to sit through that long of a lecture anyway. There's the answer. And I suppose if I'm just beating a topic to death and you get it, you could just fast forward till you get to another type of problem. That's up to you. Speaking of another type of problem, this is multiplication. So the rule is outside number times outside number, inside number times inside number. The outside number here is a 1, so we're basically multiplying 1 times negative 2. And the inside numbers are 10 and 15. 1 times 15 is 150. Now I'm going to tell you, we did it correct. We did outside times outside, inside times inside. That, however, is not the final answer. You want me to prove it? Of course you do. Don't take my word for it. Look at that. Not the final answer. Because this can simplify. 150, 2 times 75. 75, what's that? 3 times 25. 25, 5 times 5. We got a pair of 5s there. So it's negative 2, 5 squared, and then a 2, and then a 3. So that becomes negative 2. We can simplify out the 5 because a square root cancels a square. The 2 and the 3 will not simplify out. We end up with negative 2 times 5 is negative 10. 2 times 3 is 6. Negative 10 square root of 6. Was that the answer when I scrolled down a minute ago? Bingo. All right, next problem is also multiply. We have something sitting next to a parenthesis. That means multiply. So this is a multiplication problem. We also do have subtraction here. However, square root of 2 and square root of 6 are not like terms, and if we try to break this down, we're not going to get any pairs of numbers, so it won't simplify. So even though there's a subtraction here, we're not going to be able to actually combine them like up here in one of these problems. So instead, number 10 is just multiply. We're going to distribute this here and here. All right. So let's do just slowly, one thing at a time. Distribute here. The outside number is negative 4. This outside number coefficient is negative 1. Negative 4 times negative 1 is positive 4. The inside number, 3 times 2, is 6. Okay, now we need to distribute here. The outside number, negative 4 times minus 3, is going to be plus 12. The inside number, remember that was called the radicand, 3 times 6 is 18. Now, I think we can simplify this. 18 is 2 times 9, 3 times 3, there's a pair of 3's there. So this is going to be 12 square root of 3 squared times that 2. I'll just bring this down. I can simplify out a 3, square root of 2, bring this down. And then finally, 12 times 3 is 36, radical 2, 4 radical 6. That had better be the right answer, otherwise I might have to retire early. There it is. 4 radical 6, 36 radical 2. Got it. Okay, good. Number 12. Number 12 is not going to be fun. This is a FOIL problem. We have to multiply first, outside, inside, last. Okay, let's do this. Well, wait. The square root of 4. I can simplify that, and I'm going to. So watch out for little details like this. Square root of 4 is just 2, right? I think that's going to simplify the process immensely. Okay, so let's multiply here. Now, what does this 2 get multiplied by? The negative 2 or the 5 or both? Well, remember, you can only do coefficients times coefficients, radicands times radicands. This one's not technically a coefficient, but it's definitely not a radicand either. There's no radical over it. So you're only going to multiply the 2 by the negative 2. That's going to be negative 4 square root of 5. Then when you distribute here, you're going to get, let's see, negative 2 times positive 1 is going to be negative 2. Square root of 5 times square root of 3 is square root of 15. Now we'll multiply here. Plus square root of 3 times 2 is simply plus 2 square root of 3. And then plus square root of 3 times plus 1 square root of 3, that's going to be plus square root of 9. Now, will any square root simplify? Can't break down a 5. 15 breaks down into 3 times 5, but there's no pairs of numbers. Can't really break down a 3 times 1. That doesn't get us anywhere. But at the end, square root of 9 is a square number. What's a square root of 9? Hopefully you just talked to your iPad and you said 3. So we can turn that 9 into a 3, and this should be the right answer. You can't combine anything else because these are not like terms. Nothing will add or subtract with each other. Let me check number 12. If I eventually get there. And I do believe that's the right answer. Minus, minus. The only thing I don't remember are the plus and minus signs, so I got to double check if I did all that right. Yep, looks good. So, what have we looked at so far? Number 2 and your number 1 is adding, and they're already like terms. 3, 4, 5, and 6 are adding / subtracting. There are no like terms at the very beginning, but if you simplify the radicals, they turn into like terms, and then you can add or subtract them. Next, we get just multiplying, and then after you multiply, simplify. Number 9 and 10 is also multiply, but you have to do the distributive property. That's a type of multiplying, and then simplify if you can. Number 11 and 12 are foiling. So a whole lot of multiplying, and then again, simplify if you can. All right, let's look at number 14. This is also multiplying, but a higher index. But that's okay. They match, and that's all that matters. So if I want to multiply this, you do, again, coefficient times coefficient, that's negative 16. Index times index, 36 times 15. What is 36 times 15? I can't do that in my head. I have my phone right next to me. So I am about to type in 36 times 15. Actually, now that I'm thinking about it, it's really stupid that I'm doing this. Let me explain. Okay, so 36 times 15, actually it's negative 540. And I got to be sure I put my little index up there. Okay, can I simplify this? Well, first of all, when you have an odd root of a negative, which was a big part, or a major point that I made in yesterday's lesson, you can actually pull that negative out. So we end up with negative 16 square root of 540. And of course, you know what happens when you have a double negative, right? Double negative turns into positive. So this is 16 square root of 540. Okay, then what? Well, the next thing you're going to want to do is break down this into a factor tree to see if you can simplify it. Well, breaking it down is kind of the opposite of multiplying. I just multiplied 36 and 15 together to get 540. So why don't I break it down into 36 and 15? Right? I mean, just kind of undo the obvious work I already did. Now I can keep on with the tree. So 36 is 6 times 6. That's 2 times 3 and 2 times 3. And 15 is 3 times 5, right? So we're looking for 3 of a kind. Looks like I've got 3 3's. Where am I going to write this? Right here, 16 square root. I have 3 3's because I'm doing a cube root. Sorry, not square root, cube root. 3 to the third power. I have 2 2's, 2 to the second power, and 1 5. The cube root and the cube are going to cancel each other out, so I can bring out that 3. Inside, I'm going to be left with 2 squared times 5. Well, 2 squared is 4, and 4 times 5 is 20. Don't forget my index. And then outside, 16 times 3 is 48. So my final answer should be 48 cube root of 20. And yeah, 48 cube root of 20. There it is. So that was kind of a lot of work. But I kind of wondered to myself, why would I even multiply 36 times 15 and get 540 if the next thing I'm going to do is break it down anyway? Could I have done 4 times negative 4 is negative 16 and left this negative 36 times 15 and then continued my factor tree from here, 6 times 6, 3 times 5, 2 times 3, 2 times 3, you know, kind of just shorten it up a little bit. I guess it's if you want to. Okay. Number 16, kind of the same thing, except we're multiplying fourth roots together. So coefficient times coefficient. There is a 1 here, understood to be a 1, the invisible one, whatever you want to call it. 1 times 3 is 3. Fourth root. And you know what? I'm not going to do 640 times 20. I'm going to leave this, I'm sorry, 64 times 20. I'm going to leave it 64 times 20. And then just do my tree like this. So 64 is what? 2 times 32. That's 2 times 16, and that's 2 times 8. And that's 2 times 4. Holy cow, and this is 2 times 2. And 20 is 2 times 10, and that's 2 times 5. So when we're doing a fourth root, we're looking for a 4 of a kind. Do we have 4 of anything? Well, 1, 2, 3, 4 2s right there. So that's 2 to the 4th power. And then, look, another 1, 2, 3, 4 2s. That's another 2 to the 4th power. And then that extra 5 right there. So the fourth root and the 4th powers cancel out. I get 3, bring out a 2, bring out another 2. Fourth root of 5 is left over. 3 times 2 is 6. 6 times 2 is 12. 12, fourth root of 5. This is some complex math here, guys. I hope you're hanging with it. 12, fourth root 5. If you're having trouble, obviously reach out to me and I'll do everything I can to help you out. But that does it for the multiplication examples. Right? So try your best, keep organized, get help if you need it. Let's look at the rest, which is now division. How do I know it's division? There's a fraction bar in every single problem. Here, and here, and here. Okay. So, first tip was, if you can simplify anything, then do it. Here, let me share with you a little trick that makes number 18 a lot easier. Just like we had a rule that you can multiply radicands by radicands, you can also divide radicands by radicands. So dividing, well, maybe not dividing, but reducing. If you had a fraction 3 over 75, forget all the radicals and stuff. If you just have 3 over 75, that's 1 over 25. If you ever had, dealt with money like quarters, you know that 75 cents is 3 quarters. So they're divisible. Why did I erase that? So you can reduce these both by 3, divide by 3, divide by 3, and you get 1 over 25. That means I have the square root of 1 over 5 square root of 5. Oh, I'm sorry, 5 square root of 25. Now, what's the square root of 1? The square root of 1 is 1. What's the square root of 25? The square root of 25 is 5. Now I got to bring this 5 over, and then that turns into a 5, so I get 1 over 25. So I reduced the fraction first, then I did the square roots, and I ended up with nice whole numbers, 1 and 25. Let me check number 18 and see that I worked it out right, and there it is. How about number 20? Can you reduce a 4 with a 3? No, there's nothing there that'll reduce. We're kind of stuck on that. So what we have to do here is the process called rationalizing the denominator. And this was taught in another lesson a while back. So this is technically a review. I'll go ahead and teach it like everyone forgot, just in case. Okay, so you look at the square root in the bottom of the fraction, and then you multiply it by itself. But with fractions, whatever you do to the bottom, you also have to do to the top. So we need to multiply the top and bottom. Oh, do you know what? I just realized something. I'm going to get back to that. I violated one of my own rules. I said, before you do anything, simplify if you can simplify. Can you simplify the square root of 4? Duh, yeah, square root of 4 is 2. Geez, okay. So square root of 4 is 2. That gives me 2 over square root of 3. Now, we get into the dividing. We've got a square root in the denominator. You need to multiply it by itself, square root of 3. But you also have to do the top. So 2 times square root of 3 is 2 square root of 3. On the bottom, square root of 3 times square root of 3 is square root of 9. And this is a square number, which means you can simplify it. What's the square root of 9? 3. So 2 square root of 3 over 3 should be the answer. Let's check number 20 and make sure. There it is. Now I kind of flubbed that up a little bit at the beginning. Let me just reiterate. Man, if I can find it. Okay. So we started out with something that could be simplified. Do it. It makes less steps later on. So I changed that square root of 4 into a 2. After that, I got into the rationalizing the denominator part. So multiply the denominator by itself, but you also have to do the same thing to the numerator. From there, it just sort of simplifies and works out. So number 19 is going to be kind of like that for you, except I had the square root of 4, which simplified. You don't. So, but yeah, it should still work out. All right, number 22. Now, number 22 has a binomial in the denominator. That means 2 terms instead of 1. 1, 2. So for this one, you don't just multiply by square root of 2 over square root of 2, like up here we did square root of 3 over square root of 3. If I do that, when you multiply here, the 2's are going to become a 4, square root of 4, that works out. But when you multiply here, you just get 3 radical 2. And the goal is to make it so there's no radical in the bottom. So you can't just do the same trick we did up here. Then you might say, okay, well, do I just multiply it by itself and then do the same thing to the top? And the answer is no, that doesn't work. I'm not going to explain why because it would add 5 minutes to the lecture. Let's just talk about what you are supposed to do. Multiply by the conjugate of the denominator. The conjugate of this denominator is going to be 3 plus 5 square root of 2. Again, a conjugate looks exactly the same, except one has a plus, the other has a minus. Well, I just said that backwards. One has a minus, the other has a plus. Same thing. But then, what you do to the bottom, you have to do the top. You have to treat the top and the bottom the same, no matter what. Now, I realize that this is about to get in my way. So I will try to shrink that down and get it out of the way. There we go. All right, so how do we do this? Well, the top is pretty easy. Put this in parentheses and distribute. That's going to be 6 plus 10 square root of 2. No big deal. What about the bottom? Well, the bottom is going to be the big whole FOIL mess. So 3 times 3 is 9. 3 times 5 square root of 2 is plus 15 square root of 2. Negative 5 square root of 2 times 3 is going to be negative 15 square root of 2. Negative 5 square root of 2 times 5 square root of 2 is going to be minus. 5 times 5 is 25. 2 times 2 is 4. So, wow, that looks awful. Here's my fraction bar. Okay. So, can this be simplified? Of course it can. Not the top, but the bottom has a couple of things going on. First of all, positive 15 square root of 2, negative 15 square root of 2, those cancel out. Anytime you multiply conjugates, the outside and the inside always cancel each other out. In fact, since they always cancel each other out, you could just skip those two steps if you want to. That leaves us with, a 9 minus 25 times the square root of 4. But wait, you can do the square root of 4. Square root of 4 is 2. So that's 6 plus 10 radical 2 over 9 minus 50. And 9 minus 50 is a thing you can do. That's 6 plus 10 square root of 2 over negative 41. Now it is completely simplified. That should be the answer, except that I know the software that I use to make these worksheets sometimes doesn't like a negative in the bottom of a fraction. So I'm going to check it. If the answer is different, I'll explain. If the answer is the same, then we'll just move on with life. And look at that. No negative down here. So what did they do? Yeah, for I don't know what reason, a lot of mathematicians, authors, etc. are not happy with negatives in the bottom of fractions. Kind of like we're never happy with square roots in the bottoms of fractions. So to rectify this, it's just simply multiplying by negative 1 over negative 1, right? As long as you multiply the top and bottom by the same thing, it's all good. On the bottom, negative 41 times negative 1 is 41. So yeah, no more negative. On the top, you just distribute that negative 1. You get negative 6 minus 10 square root of 2. Why is this considered better? I have no idea. But yeah, it's a thing. All right, let's do 24. 24 is just another one like 22 because it's such a brand new, complicated process. A little extra practice is good. So we need to multiply this by the conjugate. The conjugate is going to be 4 square root of 3 minus square root of 2. And then you have to do the same thing on top. The top is the easy part. I'm going to do that first. So I need to distribute 2 here. That's 8 square root of 3. And 2 here. That's going to be minus 2 square root of 2. The bottom is where I get to do the whole FOIL thing. So first is, let's see, 4 times 4 is 16, 3 times 3 is 9, 16 square root of 9. Once again, the outside and inside terms, that's going to be minus 4 square root of 6 plus 4 square root of 6. They cancel anyway, so let's just save ourselves the effort and not do that part. And then the last, positive square root of 2 times negative square root of 2 is negative square root of 4. What can I simplify? Well, you can do the square root of 9, right? And you can do the square root of 4, right? The top, you can't do anything to. So I'm just going to copy that down. But the bottom, this turns into 16 times 3. The square root of 9 is 3. And then minus 2. The square root of 4 is 2. Continue to work that out. 16 times 3 is 48. And I'll just copy this down. And then finally, 48 minus 2 is 46. And then it's 8 square root of 3 minus 2 square root of 2. So a lot of steps. Some things look complicated. The better you are at mental math, I think the easier this is, but there's parts of this that I don't think are ever going to be viewed as easy. Let me check 24. I'm talking like it's all done. Oh no. Oh no. Oh no. Now what? Well, gee. Even number, even number, even number. The radicals don't really matter. Again, you can kind of treat those like variables, but the other numbers are all even. That means you can reduce this by dividing them all by 2. Good grief. So 8 divided by 2 is 4 radical 3. 2 divided by 2 is 1 radical 2. And 46 divided by 2 is 23. And that is where that answer. I'm going to erase that circle. That is the final answer. We've reduced fractions like that before when we've done the quadratic formula, so that shouldn't be too new or confusing. All right, last one. Last one's the worst one. I hate to say it. 25 and 26 are the least fun on the whole page, and the problem is there's a binomial on the bottom and a binomial on the top. So there's just going to be some more steps. The process is the same though. Multiply by the conjugate of the denominator. Remember, that's exactly the same, only with a plus sign instead of a minus sign. Or if it was a plus sign, you'd change it to a minus sign. And then do the same thing on the top. On the top, in the last two problems, all we had to do is distribute a number, and that was easy. On this problem, ugh, we need to FOIL. And I'm making a big long line. Okay, first, negative 20. Outside, negative 16 radical 5. Inside, negative times negative is positive 5 radical 5. And last, negative 4 radical 25. Now, you might be asking, why did I do the outside and inside when I didn't do that up here? It's only the conjugates where those cancel. These are not conjugates of each other. So you have to do all the steps there, the whole FOIL process. On the denominator, when you go to this part, you can do first, negative 5 times negative 5 is positive 25. The outside would be negative 20 radical 5. The inside would be positive 20 radical 5. They're going to cancel anyway, so you can get away with skipping that. And then do the last. Negative 4 times positive 4 is negative 16. Square root of 5 times square root of 5 is square root of 25. Now we need to simplify both the numerator and the denominator. In the numerator, we have like terms here and here. So I'm going to bring down negative 20. Negative 16 plus 5 is negative 11 radical 5. And then here, what's the square root of 25? You can do the square root of 25. That's 5. So minus 4 times 5. In the denominator, we also have a square root of 25. So we can simplify that, 16 times 5. But we're not done. Up here, 4 times 5, right? Negative 20 minus 11 radical 5 minus 20. Down on the bottom, 16 times 5. Grab a calculator, but I think that's 80. Yep, 80. And then we can do what? Negative 20 and negative 20 is negative 40 minus 11 square root of 5. On the bottom, 25 minus 80 is negative 60, negative 55. Wow. Now, nothing's going to reduce. If it was just 11 and 55, you could reduce those, but you also have to reduce the same thing out of all the non-radical numbers, so that 40, that's not going to reduce. We do, however, have a negative in the bottom, so we can do that step where you multiply by negative 1 over negative 1. The bottom, when you multiply this, is going to work out to be positive 55. The top, you're going to distribute here and get positive 40, and distribute here and get plus 11 square root of 5. So I'm guessing that is the right answer. I'll stake my reputation on it. 40 plus 11 radical 5 over 55. Well, my reputation was never that good anyway. How did I get an 11 here instead of a 21? Good grief. Let me check that again. Could that possibly be right? Not only that, it's a negative 21 and I have a positive 11. What on earth did I do wrong? It'd have to be the last problem too. I'm not going to reshoot this whole video because I made one mistake on one problem. I see what I did, I think. Yep. I'm a genius. Alright, way up here when I did the foiling. When I did, here, let me erase this. When I did the outside. Alright, class, what is 4 times 4? Is it negative 16? No, it's not negative 16. It's positive 16. And if that's a positive 16 plus 5 is positive 21. Which makes this a positive 21, which makes this a positive 21. And then when we distribute a negative to it, it makes it a negative 21. And that's the answer. I staked my reputation on it. Ha ha ha. So there we go. And we did check that one a while back. And I hope we checked that one too. Good golly. Coming up short here. All right, looks good. Well, the answer key doesn't have a 1 here, but that's pretty normal. You don't usually put a 1 in front of something. Okay, gonna stop there. It's been a long, long lesson. You're basically learning how to add, subtract, multiply, and divide. Dividing is really this process called rationalizing. But so much involves simplifying roots with this whole tree process that it takes us what should be a simple problem and just makes it really long. So do your best, check your answers, show your work, and if you have trouble, show up to the class Google Meet or email me or send me a comment through Google Classroom, and I'll do whatever I can to help you. Otherwise, hope you have a great day, and I'll